This video is brought to you by Azam which is one of the biggest producers of iOS development videos. I mean, just check out this. 16 courses, more than 90 hours of videos, more than 90 hours of content, and it just keeps on increasing. So by the time you're watching these, it might be like 20 courses with 120 hours, all right? And now on Azam School, I do offer the annual membership, which is $249, and monthly membership, $25 a month. And what's great about these membership options is that once you sign up for these membership, you can access to all 16 courses. And check out these amazing courses: test-driven development in iOS, reactive programming combined, Swift Vapor, server-driven UI, Reality Kit, Swift Data Bootcamp. I mean, it just contains all the things that you need to become an amazing iOS developer, and I keep on adding more courses. So there are more courses that will be added later on. So this is an amazing deal. You can check out the testimonials from our existing students, and this is again one of the largest catalog for iOS development courses. So sign up for either a monthly membership or annual membership and enjoy all of these courses. Thank you so much. Let's go ahead and get back to the video. In the last lecture, we introduced async and await, and we upgraded our fetch sources function, which is part of the web service, to use async and await. And it's working out to be great. We do have another function, which is called fetch news. And we can do the same exact thing, meaning we can remove the completion block, we can add async throws, and we can perform async and await, and we can also use URL shared.data, which is an async and await implementation. But let's assume for a minute that maybe this fetch news is a third-party function and we don't have the rights to change it. How can we make sure that we can call fetch news but using the async and await syntax? So what we're going to do is we're going to create a separate function, and we are going to use something called a continuation. Let's go ahead and get started first. I'm going to go ahead and create a function called fetch news async. Now, once again, keep in mind that I'm just giving you this demo. If you have access to the fetch news code, which you do, you can just go ahead and change the function. But we're assuming over here that we don't have access to fetch news and it is exposed by some third party. And we don't have the rights to it, we don't have the code, we cannot change it. And we do want to expose our own function, custom function, which can be called using async and await. So that's what we're trying to do. Just for the sake of simplicity, I'm going to call this function fetch news async. This function is going to take in the source ID. That is perfectly fine. It's also going to take in the URL. But it is not really going to take any completion handler because we are implementing async and await. It is going to return us the news article or an array of news article. Since this function is async, we are going to go ahead and mark this with async. Okay. Another thing that we're going to do is we will eventually find out that this function can throw an error. So we'll also mark this with throws. So what we have to do is using our async function, we need to call fetch news, which already exists. But if we call fetch news, we also have to kind of wait for it. And then once we get the result, we can tell the user that, hey, now the task is no longer suspended. You can continue the task because we got the data. And in iOS 15, Apple has introduced something called a with checked throwing continuation. And it also has some other variations like with checked continuation. We're going to use with checked throwing continuation because it allows us to throw or fire an error also. I'm just going to go ahead and call this continuation. And the with checked throwing continuation is an async, so we'll have to await. And it can also throw an error, so we'll have to do a try await. The continuation object is the one that will allow to resume from the suspended state. So inside the body of this continuation, we can go ahead and call our fetch news. Fetch news, passing in the source ID, passing in the URL. So all the work is actually done by the fetch news, which is provided by the third party. And once again, we're just assuming it is provided by the third party. We will get the result. We can perform a switch on the result case. We will have success case, which is going to give us all the news articles. And now, once we are 100% sure that we got the news articles, this can be a good way to resume from the suspended state. So we can say continuation.resume, returning the news articles. The other case that we have in this case is the failure case, which is going to return some sort of an error. And for the error case, we can perform continuation.throwing, and we could just throw the error. So now we have created another function called fetchNewsAsync, which can be called using async and await because it is marked with async. In this case, you can go and you can make your fetch news private. This means that nobody outside of this particular class can call it. Now, obviously, it's going to throw some errors because we are calling it from outside. So let's go ahead and fix that. The fetch news is being called from getNewsBy, and now we have to change it a little bit. First of all, the getNewsBy should be marked with async because we have to await for something. Let's go ahead and comment out this code first so that we have a better idea of what to do. Now I can go ahead and say web service dot fetch news async. You can see that this is a new function that we have created, and we can await for it because it is marked with async. And also we can await inside the getNewsBy function because the function itself is an async. Let's go ahead and pass in the source ID, and we will also pass in the URL, which is constants.url.topheadlinesby, and simply pass in the source ID. FetchNewsAsync function is an async function, so we will have to await for it. And we are eventually going to get the news articles because that is what's being returned. Once we get the news articles, we can loop through it and we can make sure that it is populated. But FetchNewsAsync is also a throw function, meaning it can throw an error. So we have to use try and await. And if we're using try, then we have to wrap this in a do block. So let's go ahead and wrap this in do block, catch. Once we catch the error, we can simply go ahead and print out the error. And we will move our dispatch to inside of this. Perfect. Now let's go back and see what's going on. In our view, now we have a different problem. Since the getNewsBy is now an async function, we can't really call it inside onAppear. But if you remember correctly, this is the same issue that we were facing earlier on, and we were able to solve this by using the new task modifier. The task modifier is a great place to perform any kind of operation. Maybe you want to fetch something when the view is loaded, and task modifier is already async, so you can await for different completions to happen. And we are going to remove onAppear. Since task modifier is already marked with async, we should be able to use the await feature and await for it. Let's go ahead and build our application. Looks like everything is fine. Now let's go ahead and try to run it. You can see that when we run our application, we can see all the different sources. If I click on any source, it's going to go to the news source or the news list screen, and it is able to find or load everything. For the news list screen, we don't really need another navigation view. So if you go to the news list screen, we should be able to simply remove it. So let's go ahead and remove the navigation view. Great. Now we have created our own function, which allows us to call it in an async await fashion. We use the new with check throwing continuation API, which allows us to call a function, then wait for it, and then resume it. If you have ever done JavaScript programming, it's kind of like a promise that can be resumed, which is over here, or it can be rejected, which is in the case of an error. Now, one of the other things that we would like to improve is the part where we are getting all the data and we are using the dispatch queue to make sure that the news sources are being set on the main queue. Let's see that in iOS 15 how we can easily manage our main queue so that we can be 100% sure that whenever we are setting a property which is marked with published or any other property which is part of the view model or a property or a function is called on the main thread. Let's go ahead and cover that in the next lecture. In this module, we'll be talking about structured concurrency using async and await in Swift language. We will look at many different ways where you can create structured concurrency, starting with async-let, which allows you to run concurrent tasks, task groups, which allows you to run multiple child tasks based on the groups. So if you have a dynamic amount of tasks that you want to create, task group is an excellent choice. We will also look at unstructured tasks, which means tasks that you want to execute, but they are not in the asynchronous context. And finally, we're going to look at detached tasks. We're also going to look at task cancellation, so you can cancel your task. And all of this will be explained using a real-world example of calculating the interest rate using the credit report. So let's go ahead and get started. Before we start implementing and using the new async and await features as well as group task features, we need to understand the scenario. Our scenario revolves around a user and using the user ID to find their credit score. Based on their credit score, we will calculate an APR, also known as the interest rate, for that particular user. I've already written two small services or endpoints in Node where when we pass in the user ID, it will return us a random credit score. You can see that we don't really use the credit ID. It's completely forgotten, but we still have to pass in the user ID. The two services we're using is Experian and Equifax. You can see it simply generates a random credit score and return it. So how would we implement this scenario into our application? Let's first go ahead and start by our function called getAPR. In the getAPR, we're going to be passing in the user ID. Great. Now we need to have URLs for our services. I'm going to go ahead and create a constants. And inside the constants, I'm going to go ahead and create another struct called URLs. And inside the URL, I can go ahead and create a function where you can pass in a user ID and get the Equifax URL. Perfect. The same thing we can do also for Experian. This means that we can simply go ahead and implement kind of like the same exact function, but with a different URL. So I can copy this, probably name the function Experian because this is going to go to a different service, and it will give us a credit score from that particular credit bureau also. I'm also going to create a credit score structure which can be populated. That will be our model. And I will also have an enum representing a network error. This will have cases like bad URL or decoding error. Now, if we go to our get APR function, the first thing we need to do is to get the URLs which are unwrapped into different variables. So let's go ahead and do that. We're going to create two different variables, Equifax URL and Experian URL. We will get the URLs from our constants.url.equifax, so basically this function right here. And we will also use the Experian function. If there's some problem in unwrapping those URLs, we're going to go ahead and throw an exception. So in this case, I'm just going to say this function can actually throw. And eventually, this function is going to return you the APR rate. Right now, let's go ahead and just say 0.0. Great. Now we need to make sure that we are getting the credit score. We need to get the credit score using the services that we created, one for Experian, one for Equifax. Although they do return some randomly generated scores, we're still going to use that. So we're going to use URL session.shared.data, and we can either pass in a URL or we can pass in a URL request. I'm just going to go with the URL because I already have the URL. This particular function is an async function. So we need to make sure that we are awaiting. And this function, which is the data function, can also throw an error. So we will also need to use try. This is going to return us something. It's going to return tuple with the data and the response. Great. Well, we can't really use await because our function is not really marked with async. So let's go ahead and make that change also. We can use the same exact thing, but for Experian. Let's also go ahead and change the name from data to Equifax data. And let's go ahead and copy it and do the same exact thing for Experian. We will call it the Experian data. This is the data that we are receiving from a different web service, and it's going to use a different URL. Now at this point, we may find an issue. The issue is basically, once your application reaches this particular line, it is going to await. In other words, it's going to suspend this function till we receive the actual response from the Equifax URL. This means that all the different lines that are following that line 34, 35, they can't really get executed unless and until we get some sort of a response from that Equifax URL. But what about if we can do these things concurrently? This means that this task can just start and go ahead and start fetching and getting the result from the Equifax URL. And this particular line is going to go and get the result from Experian URL using Experian API. And then they can just run concurrently. And then when they return, then we can make sure that we get the value. This is definitely going to also allow you to not wait over here and wait for the response, which may or may not take a long time. So working on these two tasks concurrently can definitely give us an advantage of not waiting sequentially for each task to just wait. But how do we do that? This is where we will have to use something called an async-let. Let's go ahead in the next lecture talk about how we can utilize async-let in SwiftUI to create concurrent task. So now let's go ahead and see that how we can run these two tasks concurrently so that one task is not waiting for another task to complete. And this can be done by using the new syntax of async-let. When you're using async-let syntax, you don't really have to use try-await on the right-hand side. What you're doing is that you're creating a variable, and that variable is holding to a reference to that particular task that is going on. So it is going to get returned immediately and going to start a concurrent task. So let's go ahead and remove the try-await from the right-hand side. This means that now async-await is going to start a task. It's not really going to suspend anything, so that other actions, other tasks can also follow suit. I can go ahead and do the same exact thing for my other task, which in this case is Experian. Now we have started two concurrent tasks, which are not blocking or suspending anything. The next step that we want to do is that eventually these tasks will need to be awaited. I can do anything over here, so this can be your custom code. After that, I'm going to go ahead and get those tasks and decode them. So I'm going to use JSON decoder.decode, decode to a particular model. This is called credit.self. From the data, which in this case is Equifax data. But if you remember that once we use Equifax, we were using async-let. So in order to evaluate this, we need to go ahead and use await. But since the Equifax data was actually used from the data, which can also throw an exception, we will use a try-await. Now we can go ahead and also add another try for the JSON decoder. This is going to return us the Equifax credit score. Perfect. It is at this point that your application will suspend because now we are awaiting for it. We can use the same exact technique to get the Experian credit score. So let's go ahead and get that also. Once again, this is expended at this point or suspended. Now we will suspend this part also. You might be wondering, okay, if we didn't really suspend, if we are suspending over here, what's the point of suspending? We should have just suspended the way that we were doing by putting a try-await over here. Well, the reason that we are not using try-await over here is because it's going to obviously suspend and you cannot do these tasks concurrently. So now this task, both of these tasks are done concurrently and eventually they are returned. Now we are capturing Equifax credit score first, but you can also capture Experian credit score because these are independent tasks. But you can also consider a scenario where you are evaluating and getting the value from one task and then feeding it to the next task. So definitely that is possible. Right now our Equifax credit score and Experian credit score are optional because we have used try optional. Let's go ahead and unwrap them. If unwrapping throws an error, we are going to throw the decoding error. Next, we need to implement our calculate APR function. Calculate APR doesn't really do much. It just takes in the credit score that you receive from different credit bureaus and sums them together and returns the average. This means we can go over here and we can call that particular function. We can call calculate APR and pass in Equifax credit score as well as Experian credit score. Perfect. Now we are going to go ahead and we're getting ready to actually call this particular function. we will call that function by calling getAPR. We need to pass in the user ID. It doesn't really matter what you pass in, so I'm just going to pass in 1. Since getAPR can throw an exception, we have to make sure that we are calling it with try. But that is not going to be enough because getAPR is also an async function, so we need to await. So let's go ahead and add await. But we cannot really await like this. We have to be inside some context. So I'm going to go ahead and use the async closure. Perfect. So this is going to perform a request and it is going to give us a credit score, or in this case an APR, hopefully. And now we can go ahead and print out that APR. Let's go ahead and run this application and see what kind of an APR we return. Keeping in mind that the APR that we're going to return will be from the fake credit score. So over here, the APR is coming out to be 798, which doesn't really surprise me. Actually, the APR calculation is a little bit different. As you can see, we are summing up the credit score and we are dividing it by count. Maybe we should also divide it by 100 or something to get an actual APR. Obviously, this is not the correct formula for calculating an APR of anything. But instead of APR, we're returning more of an average of a credit score. Okay, that's fine. 6% APR for the whole year. Great. So it looks like this is working correctly. Now, one of the other things that we need to take into account is that what will happen if we have a list of users and we want to process them one by one and get an appropriate APR for each of the users. Let's go ahead and check it out in the next lecture. In the last lecture, you learned about how you can use the async-let syntax to perform 2 concurrent tasks. This means that these tasks are not really going to wait on each other. They are just going to be run concurrently. Eventually, we do have to wait or suspend till we get the result from particular tasks. Now, what about if we have an array of IDs and we want to pass the IDs to our getAPR function to get the APR for that particular user? Let's go ahead and first create an array of some random ID. It doesn't really matter what the numbers are. Perfect. Now we can go ahead and run a loop. ID in IDs, and we can go ahead and call the function, in this case, which will be for calculating the APR, the getAPR function. GetAPR, passing in the user ID. The getAPR function itself is an async function. So when we're calling this function, we have to make sure that we are in an async closure. We can wrap this whole thing with an async so that we are inside the async closure. There we go. Now we have to await for the result from getAPR, since that is an async function, as you can see. And it can also throw, so we have to make sure that we are calling it with try. Eventually, it will return us some sort of an APR that we can go ahead and now display. If we go ahead and run this, you can see that it is displaying us the APR. All of the APRs seems like it's coming out to be the same. Let's go ahead and run it again. And you can see now it's a little bit different. So depending on the random value and depending on our formula for the credit score or the APR, it will generate some sort of an APR for that. Now, one of the things to note about the code that we have written is even though we are running it in a loop, it has to wait for the getAPR function to process so that the next particular operation can take place. So by running this code in a loop, it does not mean that you have magically created 10 or 20 concurrent processes. Since inside the getAPR function, you are using async-let, no matter what happens, you create two different concurrent processes, one for getting the data from the Equifax and one for Experian. So even though you're running this particular loop number of times, it will create two processes, and then it's going to wait for those processes to end, and then you can go ahead and run a loop again. So if you visually want to see it, it's something like this. You run a process, and now you span two different concurrent child tasks that are performing Equifax and Experian. And when these two tasks are actually done, then this is also marked done, which is getAPR, and then it moves to the next ID. But what if we wanted to perform all of these tasks in a concurrent fashion? For this, we will have to take a look at task group that allows us to do that. But before we jump into task group, there is one very important thing about our async task over here, and that is canceling a task. So let's go ahead and in the next lecture, learn about how we can cancel a particular task. All right, so now let's go ahead and talk about canceling our task. If your tasks are running, there is a probability that one of your tasks can throw an error. And that will mark the task for cancellation. Let's go ahead and see how it can happen. We will go into our getAPR function, and we will write some dummy code that will make our task fail. This means that if the user ID is integer and it is also even number, we will go ahead and throw an error saying invalid ID. This is just for testing the cancellation of the task. Now let's go back to our code and run the application. You can see that right now we're just waiting for our task to complete. But our task never returned us with anything. Eventually, it does return, and it returns us for ID number 1. Because after ID number 2, it was all not working. So let's see how we can check and handle when your tasks are being broken, meaning if there's error going on. If there is some sort of an error in the task, in the child task, we can always check using task.check for cancellation. If this is going to throw an error, then we can catch it and we can make sure that the task was not done correctly. This means we can wrap this inside do try. We can get the actual error. We can go ahead and print the error also if you want to. Let's go ahead and run this now. You will see that we got invalid ID and invalid ID. So 2 times we were able to get invalid ID. And because we are catching it, it didn't ignore the rest of the task. So even though we got the error or problem on task ID number 2, because we have wrapped up in do catch block, we were able to get it running. Now, whenever your task is about to perform operation on a list of items and at the end it just doesn't do all the list, it is very important that you make sure that which items were not processed. That's why you can tell your user that there were a couple of items that we were not able to process. And eventually, you can go ahead and list those items. This means that the user will know that these items with the invalid IDs were not really processed for some reason, and maybe the user can try it again in the future. Apart from task check cancellation, there is also task.isCancel, which is going to let you know if the task is canceled or not. So you can also use that Boolean property if that is what you need. Now we have learned about the new syntax for concurrent task and also task calculation. Let's go ahead and look into how we can go ahead and use task groups in our application. In the last few lectures, we talked about async-let. And we also tried to run a loop while the loop was calling getAPR. Now, even though we are running a loop and we are creating multiple concurrent tasks using async-let, it will only run two tasks together at the same time. And then it will have to await for the result. Sometimes we just want more dynamic behavior, meaning we want to run the tasks concurrently and we don't know how many tasks we want to run concurrently. Not two, but maybe more. In those cases, we can use something called task groups. So let's see how we can use task groups in our example. I'm going to go ahead and remove this and create a normal function. This will be called getAPR for all users. We're going to pass in the IDs, which will be simply an int. This is going to be an async function, which can also throw an exception. This function is going to return us a dictionary with int and double. The int is going to represent the ID of the user, and double is going to represent their APR that we calculated. Now, inside over here, since we do have to calculate and put the value into a dictionary, we will create an empty dictionary with int as the key and double as the value, and we'll initialize it as empty. Now we already have the code that we used last time, which is for ID in IDs, and we were calling the getAPR. But now we want to perform this action dynamic number of times, meaning we don't know. We can perform as many concurrent tasks as the IDs. So for this, we are going to wrap this with something called try, await, and a group. Now, group also comes in different flavors. We're just going to use a throwing task group, which means that it can actually throw an exception. The child task result type represents that what it is going to return us back. So I'm just going to go ahead and say nothing. It's going to return back empty. And now we can go ahead and talk about the body of this particular task. In the body, we can go ahead and put this code. So now what's going to happen is that the task group is going to execute. Also, it's going to execute the array. And within each array, we can perform the async action. This is going to create a concurrent group. And this is where we can go ahead and call the APR function, which is try, await, get APR, passing in the user ID. Perfect. At the end, we're going to go ahead and return something which will be user APR. There are a number of issues going on over here. We didn't really use that. The try is used, but this is not really throwing any exception. What's going to happen if we run this app? Let's go ahead and visualize this. This is our main task. This is going to be created for get APR for all users is since this is marked with async. From inside over here, this is going to create group. This will be the first group, this will be the second group, this will be the third group, and so on. The group will depend on the IDs or number of IDs you have. Now within each group, we are calling get APR. And if you scroll up and find out that inside get APR, we are creating two concurrent tasks. So what's going to happen is that from here, you will create one task, but you will also create another concurrent task. So you can see that all the things that you have done with async-let, you can still use even though you're using a group from the outside. So all of these tasks are now, and groups are now going to run concurrently, and inside each group, we are two child tasks running. So this is kind of like the whole diagram or the flow of all the tasks or structured tasks you will see. Now, once we get the APR, we can try to go ahead and update our user APR by providing it a key, which is ID of the user, and a particular APR, which will be the actual value. So let's go ahead and assign the APR. Unfortunately, when we try to do this, this is going to cause an error. And the error is basically saying that you are inside a concurrent task behavior and you cannot really change something that is from the outside, because this can cause data race conditions. You're writing to a dictionary and this particular thing, the group.async, is running in the form of async task. The get APR is going to return you, but we don't really know which ID is going to get returned first. It's going to be ID 1, it's going to be ID 2, we don't know. So we can't really do that. What we can do is maybe we can return from over here once you get the task. And instead of changing the user APR, which we cannot because we have declared it on line number 69, and that is not really part of that async call, so we can't really modify something that is not part of the async. We can simply go ahead and return a tuple with the first thing as ID and the last thing or the next argument would be the actual parameter value for the APR. We can remove this part, we don't really need that. Now it is going to complain that you were supposed to return a void, but now you're returning something else. So we need to update this to also say that we will be returning a tuple which will consist of a integer value and a double value. Now once it does return, so this is going to perform, this is going to await, and once it does finish, we can use a new feature in iOS 15, which is async sequence. So we can now go ahead and await for the ID and the APR in a particular group. This means that we are going to go and access these awaited items individually. Since we are accessing these items from a group, the group already has finished. So this part has already been done and we already have access to the group. That's why we can iterate through the group and get the items by awaiting. Since we're awaiting, we will process these items one at a time. And at that point, we can go ahead and update our APR or user APR. This is not really going to cause any error because we are in a sequence, and that sequence is dictated by a for try await loop. This is an async sequence that we are going to read about and learn about it, but the main thing to understand over here is that this particular sequence is going one by one because it's awaiting from a group to access a tuple. So every single time it's going to run, it's going to await for the next item to be available, And since this is in sequence, we will be able to add this value, and it's not going to be any race condition since all of these items are going in one by one as a sequence. Now let's go ahead and try to use our new get APR for all users function. We will go ahead and try to call this function from outside. We will pass in the IDs array, which is right there on the top. And this will return us the user's APR as a dictionary. Once we get the dictionary, we should be able to publish it on or print it on the screen. Sometimes you may need to call it multiple times because our data is hosted on a different part. Let's go ahead and remove this one, the error also, because it might be causing some errors. There we go. And let's try to execute it again. And there we go. So ID number 3 is 7 APR, ID number 4 with 7 APR, 7 APR, 8 APR. So it's revolving around 7 and 8 basically. There we go. You can see that the IDs that were inserted into the dictionary, they were not in sequence because they are awaiting a task to be returned, and we don't know at this point that which task is going to get returned first. So a task group is a great choice if you want to perform a dynamic behavior and if you want to perform multiple child tasks. So each group task can trigger and can create more child tasks that can go and fetch the data. In this case, we are creating 5 different groups, and each group contains 2 different concurrent tasks that are running, which are identified by async-let. So now that you have learned about structured concurrency in Swift, let's go ahead and move to more of a unstructured task. We have talked about creating structured tasks using async-let as well as task groups. But you can also create unstructured tasks. Now the question is, well, why would you need an unstructured task? A common situation for unstructured tasks is when you are not in the async context, but you do want to call a function which is async. So let's consider this example. We are using a button control over here, and this is a Swift UI view, and we want to call this particular function getData. GetData function is actually marked with async. So let's go ahead and try calling this function from the button click. I'm just going to go ahead and say getData. Now since that is marked with async, I can go ahead and await. That's the only way to call the async function. Unfortunately, the button itself is not in the same context or the async context. That's why it cannot really use the await function. In order for the button to be able to call the getData and await for it, it also needs to be in the async closure or an async context. Now we can go ahead and wrap this, and you have already seen this before, with async. Async is now replaced by task.init. If you are using Xcode later versions, you will see this warning. The warning is simply saying that async is deprecated. Async was replaced by task.init, and it will be removed shortly. So instead of using async now, you should be using task.init, which does the same exact thing, but that's a different name that they have given to it instead of async. And this might also be true for other things, like async detached will be changed to maybe task detached or something like that. But right now you can see that the warning has gone away. So task.init is going to create a closure where we can go ahead and call async function. So now we are in the async context, and we should be able to call other async functions. So that is one of the ways and one of the uses of unstructured tasks in Swift language. All right, everyone. Now let's go ahead and talk about detached tasks. Now, before I go on and explain to you what detached tasks are, let's go ahead and take a look at their documentation. So if I simply go ahead and create a detached task and click on it, I can look at the documentation over here. Now, one of the most important things you will see in the documentation is that they're saying that the creating detached tasks should generally be avoided in favor of using async function, async-let declaration, and await expressions. So in other words, Apple is also telling you that generally, in most of the cases, you should not be using a detached task. Now, why is that so? Why should we not use a detached task? Well, there are a couple of things that makes a detached task very different. First of all, it does not really inherit anything from their parent context. This means there are no priorities, task locals, deadlines, nothing is inherited. Just to give you an idea, I can go ahead and create an unstructured task over here. And inside this unstructured task, I can create another unstructured task if I want to. Let's go ahead and give this unstructured task, which is not a detached task, some sort of a priority. I'm just going to go ahead and say background. Now, since this is an unstructured task, the child task will also get the same priority, which is background. And you can always check this out. You can always say print, and then we can say task.current priority. If it is background, go ahead and print it out. Let's go ahead and run this. And you can see it returns true, which basically means that the task priority of the child task is the same as from the parent task because it is inheriting those priorities. Now, on the other hand, if we go ahead and create a detached task, so task.detach, it is not really going to inherit anything from anyone. So it's basically you are just creating it again from scratch, a detached task, hence the word detached. So what can we do in the detached task? Let's say that in your application you are getting the thumbnails and you want to perhaps run a background thread and you want to completely get detached and save something to a local cache, then you can perhaps call the function write cache to images or write the thumbnails to images. Now we can do that, and that's okay, keeping in mind that this particular detached task is not really going to be inheriting anything from their parent, which includes priorities, task locals, everything. So it's simply attached a task on its own, which is responsible for writing something to the cache. In general, you should avoid using detached tasks where necessary and use the structured concurrency model using async-let and await and actors and all of those different features of the Swift language. So that is the detached task in Swift language.